Distinguished colleagues and guests, good afternoon. It's the 22nd of December, the shortest day of year 2021, 3 p.m. Moscow time. And we're beginning the panel session for the defense of the thesis by Abdelghany, Abdelrahman, and Mohamed. The thesis is submitted for the academic degree of Candidate of Sciences in Chemistry. The specialization is 147 macromolecular compounds. The topic of the thesis is the influence of surface properties of biocompatible polyester-based particles on biointeractions and drug release kinetics. Under the order issued by the Academic Secretary of St. Petersburg State University, Alexander Gnotov, as of October 8, 2021, number 9655/1, I, Mikhail Krasavin, Doctor of Sciences in Chemistry, Professor and Head of the Department of Natural Compounds Chemistry of St. Petersburg State University, was appointed the Chairman of the Board. The order also approved the candidacies of other members of the board, and let me introduce them. Elena Grachova, Doctor of Sciences in Chemistry, Associate Professor, and Professor of the Department of General and Inorganic Chemistry of St. Petersburg State University. Nikolai Tsvetkov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Molecular Biophysics and Polymer Physics of St. Petersburg State University. The following members of the board are working remotely today. Alexander Garabacho, Doctor of Sciences in Chemistry, Professor, Vice Rector for Science at the St. Petersburg State Institute of Technology. Alexander, do you see and hear us? Yes? Yes, everything is okay? Okay, great. And Vitaly Khotaryansky, PhD, and Professor of the University of Reading, the United Kingdom. Vitaly, you hear and see us? Yes, I do. And our candidate for the degree today is Abdelghany, Abdelrahman, Mohamed, and Tatiana Tennikova, Doctor of Sciences in Chemistry, Professor and Head of the Interdepartmental Laboratory for Biomedical Chemistry of the Institute of Chemistry of St. Petersburg State University, is the thesis supervisor. And I would also like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted from Russian into English and vice versa. Currently, we have an email address posted on the page with live broadcast of the board session. And all listeners can submit their questions to Mr. Abdelghany online, the questions regarding the thesis or the scientific discussion, or they can submit their opinions. And thus they can participate in our discussion. These questions will be forwarded to me by our technical service, and I'm going to read them out during the discussion. The questions must be related to the presentation and the content of the thesis. And do not forget to give your name and position if you submit a question. And I should note that questions that have nothing to do to the scientific discussion, to the text of the dissertation, to the assessment of the thesis will not be voiced, as well as anonymous questions. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local regulatory acts of the university, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. And the total number is not to be fewer than 4 people. The Dissertation Board consists of 5 people. Everyone is here today, including 2 members of the board who are participating remotely. And we have a multimedia connection with both of them. Therefore, we have the quorum. Therefore, I kindly ask the representative of the Department of Dissertation Board Support to fill out the attendance list. Now, a few words about our agenda. It is quite strict, and our session should not last more than 2 hours. So the overall agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements of the university, and chairman's replies to questions, if any. 5 minutes will be given for that. To be followed by the candidate's presentation, providing an overview and the findings of the research. And the candidate for the degree has 20 minutes to deliver his presentation. Then we're going to listen to the questions to the candidate regarding the presentation. 2 minutes per question, please. The candidate's replies to the questions will follow. Then we're going to listen to the reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions to the candidate for the degree. And maybe discuss some proposals for future studies. 10 minutes will be given to every board member. Then I'm going to read my report on the thesis as a chairman. Then the candidate will comment comment on the reports on the thesis and reply to the questions. I believe we are going to do it after each review, so you'll answer the questions after each review. It will be easier. Then we're going to have an open discussion, speeches of those present at the defense, with a brief presentation of their positions, or maybe specific questions or suggestions to the candidate on the topic of the research. 2 minutes per anyone willing to take the floor. And don't forget to state your full name and academic rank, position, and the place of work in the registration list. Then the chairman will ask the questions submitted during the broadcast via our website. And I would like to draw your attention to the fact that those written questions that will take more than 2 minutes to read will not be voiced. Then the candidate's replies to the questions. Then we're going to listen to the speech of the candidate's thesis supervisor. 3 minutes will be given to Tatiana for that. Then we may have a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree to the candidate. The discussion of the results of the defense is not broadcast, so we're going to decide whether we need this 5-minute break or not. Then the most important part, open balloting. And as a chairman, I'm going to ask all of you about your opinions, whether you support the thesis, and finally I'll give my opinion as well, and after that we're going to count the votes and make a decision on whether to confer the academic degree or not. And finally we're going to listen to the closing remarks of the candidate for the degree. That's it. Any questions, dear colleagues, about it? Okay, no questions, no objections. Therefore, let us proceed. But before we do that, please kindly switch off the sound on your mobile phones. Thank you. And let me start. So initially the short presentation, chairman's presentation about what we plan to listen to. The thesis by Abdelghany, Abdelrahman, Mohamed Ali for the academic degree of Candidate of Sciences in Chemistry. The specialization is 147, Macromolecular Compounds, is titled The Influence of Surface Properties of Biocompatible Polyester-based Particles on Biointeractions and Drug Release Kinetics. So the thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University as of September 21st, 2021, number 907/1. Mr. Abdelghany has prepared his thesis at St. Petersburg State University as a postgraduate student, and I've already introduced his thesis supervisor. Two published works describe the research findings, and both works are published in journals indexed in Web of Science and Scopus. And all the provided documents, as far as I'm informed, comply with the requirements of St. Petersburg State University, and they are found in the certification file of the candidate for the degree. And the curator of the defense, the member of the Department of Dissertation Board Support, has all the copies of these documents. And before I give the floor to our candidate for the degree, I would like to ask the members of the board. So, distinguished members of the board, are there any general questions to the candidate for the degree? Is there need to consider the whole list of documents submitted by Mr. Abdelghany? I believe there's no need for that. Yes, I agree. No need for that. Okay. Then I give the floor to our candidate for the degree for the short review, 20 minutes. Please, the report will be delivered in the English language. Abdelghany, Abdelrahman, Mohamed Ali, so please, you have the floor.
The members of council, let me present the results of my thesis work for the degree of candidate of chemical sciences on the topic, the influence of surface properties of biocompatible polyester-based particles on biointeractions and drug release kinetics. Let's be.
Коллеги, я должен объявить технический перерыв номер 1.
Dear colleagues, I announce the first technical break.
Настройка звука для перевода.
Hello? Hello? Do you hear me? Hello? Hello? Is it okay? One, two, three, four. 1, 2, 3, 4. Hello? Hello? Okay. Do you hear me now? Do you hear me? Okay. Louder. Hello? Hello? Okay.
Отлично. Технический перерыв номер 1 закрывается. Продолжаем заседание.
Okay. Let's begin with a brief introduction, then talking about essential parts in the work and conclusions by the end. Aliphatic polyesters-based materials represent an important field of research due to their prospective and widely used applications in biomedicine. Among them, the formation of scaffolds for tissue engineering and the particles for drug delivery systems are considered as leading applications, owing to their excellent biocompatibility, biodegradability, and ease of processing. However, polyester-based material have a definite inherent drawbacks which limits their application. Firstly, their significant hydrophobicity should be noticed, which contributes to non-specific cell and surrounding tissue interactions. And the second negative feature is the lack of accessible reactive groups available for biomaterials, for bioligands attachment, which is important for strict targeting of such particles. And the burst release behavior is also one of the drawbacks of such particulate delivery systems. The intensity of this burst depends on particle hydrophobicity and polymer material crystallinity. Moreover, the surface composition could be an important factor in the determination of drug release kinetics. To date, extensive studies have been performed mostly on the functionalization of polyester nanoparticles in order to improve drug delivery behaviors of designed particulate system, as well as to effectively control the pattern of drug release. It was shown that the drug release profile from nanoparticles can be optimized by physicochemical changes, physicochemical properties such as size, material composition, and surface characteristics. On the other hand, the physicochemical changes resulting from continuous development of such nano carriers may significantly impact their biological properties, and hence understanding the process of cellular uptake is crucial at designing a safe and efficient nanomedicines. Despite quite broad research performed in polyester particles, the systematic studies aimed to reveal the effect of different particle parameters on drug release kinetics and biological properties are met quite rarely. So, the general aim of the work is to provide a systematic study which will compare the effect of particle size and surface charge of polyester-based particles of different hydrophobicity on drug release kinetics and on their internalization into different types of cells. In order to reach this goal, we have performed firstly synthesis of a series of biodegradable polyesters of different hydrophobicity for particles preparation, development of methods of efficient encapsulation of hydrophobic model drug prednisolone inside micro and nanoparticles based on synthesized polyesters, development of methods of particles surface modification with hydrophilic charged polymers labeled by neophosphorescent metal organic complexes, and to perform a drug release study in order to conclude the effect of particles surface charge on release kinetics of encapsulated drug. And finally, to study the effect of particles charge on cells viability and to establish the ability of particles to the interaction with cell membranes and intracellular penetration. In current study, 3 different biodegradable polyesters were synthesized, namely polylactic acid, polycaprolactone, and polybentadicalactone. The synthesis of polylactic acid and polycaprolactone was carried out via chemically initiated ring opening polymerization in the presence of stannous actuate as a catalyst, while the synthesis of more hydrophobic polybentadicalactone was obtained via enzyme-mediated polymerization. One can observe that the obtained polyesters in current study possessed with controlled molecular weight and narrow enough molecular weight distributions. All of polyesters obtained in current study were applied for fabrication of microparticles and nanoparticles via optimized single emulsion and nanoprecipitation methods respectively. The characteristics of prepared particles are presented in table. Firstly, the particles obtained by emulsion approach possess greater size than those obtained by nanoprecipitation, and they were labeled as microparticles and nanoparticles. Zeta potential of formulated particles is negative, which is due to the presence of carboxylic group on their surfaces, and finally the encapsulation efficiencies of nanoparticles exceeds those for microparticles in current study. Here, in order to prepare particles with different hydrophilicity and the charged layers on their surface, 2 biodegradable polyelectrolytes, namely polylysine and heparin, were applied to alter the surface charge of the particles. In order to do that, the partial hydrolysis of particles surface was performed using short treatment of sodium hydroxide, followed by a subsequent activation of formed carboxylic group with carbodiamide in order to activate them towards amino-bearing polymer polylysine. the attachment of polylysine to the surface of particles changes all particles the surface charge to positive values compared to initial particles, while the attachment of heparin results in the formation of negatively charged particle surface. These observations indicate the successful attachment of charge inducers to the surface of particles. The contact angle of polyester-based films of the same nature decreased upon modification with polylysine and heparin interpolyelectrolyte layers, indicating the more hydrophilic properties of the surface. Moreover, the encapsulation efficiency of prednisolone formulations based on modified particles seems to be lower than that of initial particles, probably as a result of prednisolone leakage during particles modification process. In current study, in order to monitor the attachment of hydrophilic charged layers on the surface of particles and to investigate their internalization into different types of cells, two near infrared emitting phosphorescent organometallic complexes, namely platinum and iridium complexes, were applied to prepare the labeled particles. These complexes were used to prepare luminescent micro and nanoparticles of crucial morphology as presented in the scheme. Firstly, phosphorescent probes were covalently conjugated with polylysine via lysine epsilon amino group and using N-hydroxysuccinimide activated carboxylic group of the probe. The conjugates obtained were then used to cover micro and nanoparticles by the reaction between N-hydroxysuccinimide activated carboxylic group on the surface of particles with the rest of amino functions in polylysine in order to form eventually positively charged particle surface. The obtained by this way particles were then non-covalently attached with heparin in order to prepare devices with negative surface charge. Here, the covalent attachment of polylysine probe conjugated to the surface of particles reverses their charge to positive values, whereas additional electrostatic attachment of heparin results in return to the total negative charge of devices. These observations clearly indicate the successful approach of particle surface modification with the charge inducers. Moreover, in order to evaluate the number of probe molecules bound to the particles, it was estimated photometrically with application of preliminary plotted calibration curves. And here, the number of probe molecules per particle was found to be essentially higher in the case of microparticles as compared to nanoparticles. And the formation of polyelectrolyte layers on the surface of particles has led to an increase in particle hydrodynamic diameters. Finally, to study the differences in particles size and their morphology after modification, we have applied scanning electron microscopy and the transmission electron microscopy analysis. And this microscopic analysis didn't show any significant variations in these characteristics after particles modification with polylysine and heparin. Also, the presented images revealed the presence of nano-sized, isolated nano-sized particles, which are of the same size and morphology in the case of both polylactic acid and polycaprolactone-based structures. Also, the conjugates obtained in current study, as well as labeled particles, were luminescent, and their excitation and emission spectra were found to be essentially similar to those obtained for initial complexes. These observations clearly indicate the retaining of chromophore nature upon bending to the polymer and the further immobilization onto polyester-based micro and nanoparticles for drug delivery. The first objective of current study was to elucidate the effect of surface properties of polyester-based micro and nanoparticles of different hydrophobicity and release kinetics of encapsulated model drug prednisolone. The drug release study of prednisolone from drug-loaded particles formulated from polylactic acid and polycaprolactone are during 30 days and 6 hours are presented in figures. One can observe that the more rapid release of nanoparticles formulations as compared to microparticles formulations. It's also interesting that non-modified micro and nanoparticles possess initial burst release stage with more than 50% of prednisolone were rapidly released at this stage during the first 2-3 hours. Introduction of polylysine and heparin layers to the surface of particles here minimizes such burst release, and notably particles covered by 2 layers of polyelectrolytes show even release profile without initial burst. This could be referred to the action of 2 factors, namely decreasing of drug loading as a result of drug leakage during particles modification process and the formation of hydrophilic layer on the surface of particles. This layer could serve as additional barrier for drug diffusion, which help to prolong the drug release. Generally, the obtained prednisolone formulations based on modified micro and nanoparticles allowed sustained release of the drug during more than 30 days. In current study, in order to analyze and compare the mechanisms of drug release, the obtained experimental results were approximated with application of a number of kinetic mathematical models. And here we can notice that the application of parametric models such as Korsemeyer, Bibas, Saline, and Vibol allows the best fitting of obtained experimental results. The determination coefficients here are very close to 1, thus the calculated parameters could be considered as confident, and the value of n parameter from Korsemeyer Bibas model confirms that the main mechanism of drug release is efficient diffusion. The previous suggestion was supported by the low fitness of obtained experimental results with Hickson, Crowell, and Hopfenberg models, which were used to describe release behaviors of erosion mechanisms. Thus, the performed study of prednisolone release from modified micro and nanoparticles modified by polylysine and heparin interpolyelectrolyte hydrogel corona allows to conclude that the drug release is affected by particle size and surface modification. In current study, in order to assess the suitability of developed particles formulations as drug delivery systems, the in vitro cytotoxicity of polyester-based particle formulations was performed by applying cell titer blue cell viability assay and using mouse fibroblast cell line at 2 different concentrations, 0.5 and 0.05 milligram per ml. And the presented images illustrates the viability of cells after incubation with labeled particles during 24 hours. Overall, the viability of cells was higher than 80% for the most of samples, which is indicative of a good in vitro biocompatibility of the developed particles formulations. Finally, the screening of particles of different size and surface charge into the screening of internalization of particles modified of different size and surface charge into mouse fibroblast cells was tested and compared, and obviously all types of tested particles penetrate the cytoplasm of studied cell types efficiently. However, the degree of cell internalization, which was estimated by the fluorescent particle area related to the number of cells, was different. We can notice that the more rapid release, the more rapid uptake of nanoparticles compared to microparticles formulations, and surprisingly, we found that the uptake of nanoparticles covered with polylysine was less pronounced than that of nanoparticles covered with polylysine and heparin. The observed difference could be explained by the difference in interaction of particles with serum protein from the cell culture medium, where the negatively charged albumins are the major components. In the case of microparticles formulations, which possess a smaller specific surface area, the situation is different from which observed for nanoparticles. Microparticles covered with polylysine seems to be less affected by albumin absorption and penetrate the cell interior more quite efficiently, while the minimal cell penetration capability was observed for microparticles covered with polylysine and heparin. In order to analyze and to compare the rate of particles uptake, we have performed the flow cytometry experiments with application of fibroblast particles. And the study of particles charge effect on uptake of nanoparticles presented in figure A and microparticles presented in figure B supports the data of cell imaging. Nanoparticles covered with polylysine and heparin seems to be rapidly entered into the cells as compared to nanoparticles covered with just polylysine. And the rate of the latter is very close to the rate of uptake of microparticles covered with just polylysine. Similarly to cell imaging results, the slowest cell uptake was observed for microparticles covered with polylysine and heparin, and overall the cellular uptake of microparticles was lower than that of nanoparticles. To conclude, a series of different biodegradable polyesters, namely polylactic acid, polycaprolactone, and polypentadecalactone, were synthesized and used for particles preparation. An efficient method of producing near-infrared luminescent micro and nano particles of crucial morphology and with different surface charge has been developed. The investigated luminescent micro and nanoparticles were stable in aqueous media, non-toxic, and displayed emission, the spectra of which were essentially similar to those of unconjugated metal organic complexes. For the first time, a systematic semi-quantitative study of the effect of the particles' size and surface charge on their intracellular penetration into different types of cells, namely cancer cells, stem cells, and fibroblasts, have been introduced. The possibility of applying activated platinum and iridium emitters for labeling drug delivery systems and biomolecules containing available amino groups to study their biodistribution was successfully demonstrated. In this work, polyester-based micro and nanoparticles were successfully prepared and encapsulated and characterized as carriers for prednisolone model drug. The formulated particles were modified with biodegradable polyelectrolytes to turn surface charge. And finally, the possibility to control the release rate by adjusting the thickness and the content of coating layer was shown. The smaller size of particles, the greater release rate could be expected. As the main mechanism of drug release during the first months is diffusion, the surface hydrogel layer will definitely affect the release rate, making it more sustained. These results suggest that it would be possible to design particles with different release rates by optimizing the nature of coating layer. On the topic of thesis, 3 works were published, including 2 articles. The articles have been published in highly rated scientific journals, indexed by Web of Science and Scopus database. And finally, thank you very much for your attention.
Спасибо большое.
Thank you very much. I have a question to the members of the board. If there are any questions on the report. So 2 minutes per question if there are any. So I would like to ask a question. Yes, sure. Could you please flick to the slide number 14? Slide number 14. If I got it right, you considered the release of a medicinal product from nanoparticles in certain time period. Could you please tell me how you controlled the concentration of a released product? Подождите, пожалуйста.
Calibrated the drug itself just to be able to calculate how much drug released at a specific time. At a specific time intervals, we withdraw the supernatant and measured absorbance, and from calibration curve we calculated how much drug released at this time, and so on. This at certain time intervals we calculated how much drug, and then calculated with respect to the initially encapsulated drug inside these particles.
Thank you.
You're welcome.
Коллеги, еще вопросы, пожалуйста.
Other questions, if there are any?
So most of your nanoparticles, they're charged. They have a charged surface, right?
Yes.
And yet they get into the cells. So they have to cross the phospholipid bilayer, which is distinctly hydrophobic in nature. How do you see that happen? What's the mechanism of a charged nanoparticle getting through the phospholipid bilayer?
Phospholipid bilayer.
Сам он по себе негативно заряжен. Это негативно заряженная поверхность, и наши наночастицы и микрочастицы, у них как раз негативно заряженная поверхность. В нашем случае мы модифицировали поверхность обеих частиц, чтобы изменить заряд на позитивный и негативный, чтобы помочь прикреплению наших частиц к фосфолипидному слою и чтобы контролировать поступление в клетки. Понял вас? So let us switch to the speeches of the board members with their reviews and assessment of the thesis. So with proposals to the author, and we may take external reviews as well, if there are any. So I offer to answer questions at once after each review, as all the reviews were already published on the website. In order to reduce the time of our session, I kindly offer to give just the basic points in your reviews. Any objections about it? No? Okay. Now, I would like to give the floor to Елена Gracheva. So, please, Professor, you have the floor. Thank you so much. I won't read out my review, as it was already mentioned. My review mentions the compliance of the topic with the specialization 147 macromolecular compounds. I also mentioned the relevance, the scientific novelty. I also say a few words about the experimental part of the research, and I would like to read out one point that seemed the most important for me from the point of view of the importance of this work, that the results and systemic data on the impact of the size of particles and charge on the surface, on the penetration to different types of cells, and on the kinetics of release poses a potential interest for the design and development of real systems of delivery. And I believe that's the most practical value and relevance of this study. I had no problems with the experimental part, with the description of the results, and with the interpretation of the results. I had no comments about the text of the thesis. Beg your pardon, don't see the part that I wanted to read. Oh, here it is. Lost this part in the text. So it's easy to understand all the material, as I've mentioned, it is well written, but still it's unclear. How exactly did you use radium complexes as luminescent markers experimentally? So how did you implement the excitation of photoemission and in one channel at wavelength? Did you collect the light? And you don't mention how you concerned, or whether you concerned, the quenching of phosphorescence by molecular oxygen. And that is an important point for photophysical studies. Overall, I should say that the thesis of Abdelghany, Abdelrahman, Mohamed, titled The Influence of Surface Properties of Biocompatible Polyester-based Particles on Biointeractions and Drug Release Kinetics, meets all the formal requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Abdelghany, I believe, deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 147, Macromolecular Compounds. That's it. Thank you. Thank you so much, Elena. Now, the review of Professor Tsvetkov. Oh, I forgot. You can answer. Yes, we've agreed upon that. I beg your pardon. So please.
I'd like to thank you for your valuable comments. The first comment about how exactly the radium complexes were used as luminescent markers, and how the excitation was realized, and at what wavelengths of photoemission the light was collected. Based on the aim of current work, the radium and the platinum complexes, as well as obtained polyesters, were used to prepare luminescent micro and nanoparticles of core shell structure, where the core consists of unmodified polymers and the shell is formed by covalent conjugate of polylysine with platinum and the radium complexes. In some cases, the particles were additionally covered with heparin to inverse the species charge from positive to negative. The obtained particles were tested towards their ability to penetrate into different types of cells, namely cancer cells, stem cells, and fibroblasts. And the particles internalization studies was performed using confocal microscopy, and the cells were simultaneously imaged with DABI at excitation and emission 358 and 461 nanometer respectively, while the probes were visualized with excitation and emission at 510 and 760 nanometer respectively. For the second comment concerning the quenching of phosphorescence by molecular oxygen, indeed we didn't take into account the quenching of phosphorescence by molecular oxygen in our experiments on bioimaging, because such a task wasn't set, and this quenching is insignificant. Colleagues from Professor Sergei Tonik research group have found the excited state lifetime values, and hence the quenching of phosphorescence in particles occurs only to an insignificant extent. These values decrease by about 10 up to 13% when comparing the irradiated and irradiated suspensions of nanoparticles. This weak quenching of phosphorescence is probably due to the protection of these chromophores inside nanoparticles, and since this quenching turned out to be weak, and the purpose of this bioimaging experiment was just to visualize the required area and not to determine the content of molecular oxygen, so this quenching wasn't taken into account.
Thank you. I'm happy.
Okay.
So, Nicole, please, you have the floor. Distinguished colleagues, I won't read out my review as well fully. I would like to dwell upon just the basic points and those issues and remarks that I had when I read the thesis. First of all, based on what I wanted to mention as for the relevance of the study, so you see that detailed study of physicochemical characteristics of macromolecules that act as a carrier of medicinal products It's carried out for a long time, but it's still relevant. The thing is that quite frequently the development of new medicinal forms, including polymer ones, it exceeds and advances these detailed studies. Therefore, they are somewhat empirical, these studies, and medicinal products are already created, for example, but we don't have an in-depth understanding of all the physical chemical properties and processes, and this in turn may lead to negative consequences, side effects, for example, that were not initially taken into account. Therefore, the detailed development from the point of view of physics and chemistry of the process is of paramount importance, and certainly these studies should be conducted in the future. The thesis itself is written quite well. The structure is a traditional one. It contains 3 chapters. I won't read it out in details, but I would like to mention the results that are most impressive from my point of view, that are key ones. And for me as a physicist, they were most interesting. First of all, the work established that the size of particles plays a decisive role in adhesion based on polyelastin. The modification of surfaces of nanoparticles with polyelectrolytes can give us the master change of this charge on the surface, and an important conclusion was being made that it's possible to finally regulate the uptake and the release by the optimization of superficial layers. And now a few words about the range of remarks that I had. Well, the first remark is, quite formal, because in the Russian version you translate the drug as narcotic drug, but that's basically not a problem at all. As for the content, on page 156 of the Russian version, you write that a DLS method is a statistical approach that provides for a strict spherical form of the particles, and the results depend on this supposition that in many cases can be incorrect. And here I cannot agree with the author, because the thing is that dynamic scattering method allows us to experimentally define the coefficient of progressive diffusion of molecules and particles, and further interpretation depends on the need to choose some or other form of this molecule, but it should not be spherical, essentially. If you choose a model of sphere and use Stokes-Einstein, then certainly this approach is relevant for spheres, but you can choose ellipsoid model, extended ellipsoid method, for example, as well. Then, next remark, essential remark, is associated with the text on page 182 of the Russian version. It says, the assessment of the size of particles using DLS showed that all nanoparticles demonstrated nearly the same diameter, and the author gave the size with a possible error. And as for microparticles, they showed significant scatter of diameter. And as for dynamic light scattering, this diameter scatter is hard to define, and in this case, this dynamic scattering light method is more of a qualitative rather than quantitative one. And when you use this method, you need to understand that the goal that you meet from the point of view of mathematics, that's a goal that is not correct. Therefore, it depends on the choice of initial parameters and on the parameter of regularization. Therefore, the assessment of polydispersity would look more correct if you choose the method of microscopy. And by the way, microscopy is represented quite well in the work. And the next remark to this question, the relative scatter and variability in size is nearly the same, but the thing is that some particles are 10 times larger than others, therefore the scattering size is 10 times higher as well. And yet another comment, that's not a question but rather a comment on the providing of results. The thing is that distribution function that is obtained by dynamic scattering. All these functions are given in the appendix, but in the work they are so small that you can't read what's written on the axis, and all the graphs contain several curves. And what do these curves mean? It is not quite clear, different concentrations or something else, and it's unclear whether you conducted measurements at different angles. And what were the angles that you used to obtain the images that you showed in the thesis? And did you do extrapolations for solutions? Did you study concentration dependencies for micro and nanoparticles? So that's basically it. And certainly it does not, all these comments do not compromise the overall high value of the thesis. And the last part that I wanted to read is as follows: the dissertation of Abdelghany, Abdelrahman, Mohamed Ali, titled The Influence of Surface Properties of Biocompatible Polyester-based Particles on Biointeractions and Drug Release Kinetics, meets the requirements of the order as of September 2016 on the procedure of granting academic degrees at St. Petersburg State University. Mr. Abdelghany deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 147, Macromolecular Compounds, and Articles 9 and 11 of the above-mentioned order are not violated. Thank you so much, Nikolai. So you can answer.
For reading. The first remark about translation of the word drug in Russian version. I agree with the remark. Obviously, it's a mistake made by me upon translation. The second comment about possibility to analyze sizes of particles other than spherical ones using dynamic light scattering. I thank the reviewer for this comment. I agree that the interpretation of data obtained via dynamic light scattering method for the analysis of the sizes of studied particles as a rule is based on Stokes-Einstein relation for spheres, and this doesn't prohibit the use of other models. Within the part of the text under discussion, namely on the page 156, we were intended to illustrate the importance of alternative microscopic methods, such as scanning electron microscopy and transmission electron microscopy, which provide a visual and informative images towards a clear description over the population of nanoparticles. At the same time, the use of two independent methods such as electron microscopy and light scattering allows sufficiently complete characterization of the particles. For the third comment, assuming that the correct way is to estimate polydispersity or deviation from the average size from microscopy data, the particle distribution index evaluated by standard procedure with application of Malvern, Zeta Sizer, and corresponding software, I absolutely agree with the reviewer that the obtained values are more qualitative than quantitative. However, I wanted to point out that all polyester-based particles showed a unimodal and quite narrow size distribution, revealing their stability and uniformity. I agree with the reviewer that microscopic methods such as scanning electron microscopy and transmission electron microscopy could provide a visual and informative picture toward this particle's average size and size distribution. We have applied these methods for particles characterization. However, dry particles dimensions after lyophilization are different from those in suspension. Drying leads to compactization, and freezing usually results in aggregation of particles. Thus, the combination and the comparison of dynamic light scattering and microscopy was used in this research to analyze the particles' dimension, and I agree with the reviewer that the distribution within two types of particles was nearly the same. Regarding the questions mentioned in the fourth comment, there are several curves on each graph presented in the appendix, but what do they correspond to? The presented graphs show the size distribution diagrams obtained by dynamic light scattering for unmodified and modified micro and nanoparticles formulated from polylactic acid and polycaprolactone. The second question, at what scattering angle were these curves obtained? The standard scattering angle, 163, was applied for measuring. The last questions, where measurement is performed at other angles, and what and was the diffusive nature of the observed relaxation proved? Where is the concentration studies of the diffusion coefficients of nano and microparticles carried out? Actually, we didn't perform such a type of experiments because they were out of the research interest for us. But however, we are interested to perform such experiments in the future work.
Спасибо.
Thank you so much, Alexander. Garabadziu, please, your review. Distinguished colleagues, once again, hello, distinguished chairman, and the members of the board who are working offline have already performed the major part of work for us, but as I won't hide it, I was really pleased to read this work. I wanted to mention that when I wrote my review, I wanted to comment on the thesis as well, and some sections of the work should be outlined. First of all, to my mind, the relevance of work is associated with the fact that the attempt to have direct delivery in combination with extension of activity, that's the central problem for medical chemistry, for biochemistry, and for practical medicine. That's quite obvious. And in my practice, I mostly worked with liposomal technologies, and the fact that now I had an opportunity to get acquainted with the works that describe biodegradable polymers as particles, so I was really fascinated to read about it. And here I would like to draw attention to the fact that the use of polyesters allow to encapsulate not just low molecular ligands, but also proteins, which is not always possible when we talk about liposomal technologies. And when I started the work, I had no questions, but now, seeing this work overall, I formulated a question for myself, and in my short report I'm going to mention it later on. If we get back to the content of the work, I wanted to mention that, in fact, the author successfully managed to conduct a comprehensive range of experiments, and he mastered contemporary physics, chemistry, biochemical, and biotechnological methods. He created polymer particles of different size, and also he modified the surface of them with a variability of charge. We all see it. The major achievements that I wanted to mention, first and foremost, and certainly, by the way, all of these achievements have scientific novelty. I would like to mention systemic study of the impact of size and charge of the surface of polyester particles with different hydrophobicity on the efficiency of drug release. And I would like to mention that quite successfully he chose the medication, because prednisolone is studied quite well, and the attempt to study it on these objects is, I believe, quite comfortable, so to say. And I would also like to mention detailed studies of internalization of marked polyester particles of different nature and size. And certainly I'm ready to support the opinion of one of the members of the board who drew attention to the fact that the work is quite rational, in a sense that it allows to further on design new systems of pharmaceutical molecules delivery. And in conclusion, I would like to say that the works that the author published, I've seen these works, they reflect the content of the work. Therefore, as for the goals, as for the relevance of this, for the scientific novelty, these study is a finished dissertation work, and I would like to mention my question before I read the conclusion. I would like to solicit your opinion on the following issue. What principle did you use to choose 3 groups of polyesters, polylactic acid, PCl, and PPDL? So what was the principle that you were based on when you chose these objects? And in conclusion, I would like to read the standard phrase that the thesis by Abdelrahman, Mohamed Ali Abdelghany, titled The Influence of the Surface Properties of Biocompatible Polyester-based Particles on Biointeractions and Drug Release Kinetics, meets the requirements of the order as of November 19th, 2021, on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Abdelghany deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 147, Macromolecular Compounds. And that's it. Thank you.
Спасибо большое, Александр Васильевич. Был сформулирован...
So a question was mentioned.
Question for you. So the question by Professor Gorbachev was, what was the principle, what was the guiding thought behind choosing different polymers?
Okay. The aim of our work was to prepare particles of different hydrophobicity. So we have chosen such type of polymers based on their properties, as they are hydrophobic, and also of different hydrophobicity. For example, polylactic acid, it's quite of lower hydrophobicity compared to the more hydrophobic polymer, polybentadicalactone. And so we decided to use such type of polyesters to prepare particles of different hydrophobicity. This is a principal idea.
Okay. Переходим.
Now we're going to listen to Vitaly Khudaryansky. Vitaly, do you hear us? I do. Okay, so your review. Distinguished colleagues, I won't read out my review. I'll just say that I liked the work a lot. The author really carried out huge work. He obtained a lot of different particles with 3 hydrophobic cores of different polymers, and these particles were then modified. They were micro and nanoparticles, and he studied the colloidal chemical characteristics as well, and encapsulation of drugs and drug release as well. And in the second part of work, the author carried out modification of these particles using luminescent methods, and he considered the characteristics of these particles, how they interact with different biological objects like cells. So overall, that's huge multidisciplinary work that included both chemical synthesis of polymers, the modification of particles using electrochemical interactions, using layer-by-layer coating method, and then the author studied colloidal characteristics. And therefore I like the work a lot, because essentially, as I worked a lot with such systems, I understand how complicated it is and what problems will the author see at every stage. The work is published in 2 very good journals, and this emphasizes the novelty and the importance of work, especially by conjugated chemistry journal. It's not that easy to get there from the first attempt. Therefore, I support this work, and when I read this thesis, I had just editorial comments, negligible ones, to the translation. But during the defense, I drew attention to the fact that these delivery systems were aimed for the delivery of prednisolone, and in articles you write it. And therefore, I have an additional question. It's unclear why, if that's a delivery to the eye, so are these drops, as you mentioned in the article, or is it an injection? But in both cases, it's not clear. Why did you study the release for 700 hours? Not on the surface of the eye, not inside the eye. I believe it's not possible to achieve such a time during the release of the drug. But still, that's not a serious comment, and I support this work, and I believe that I'm not sure whether I need to read this standard phrase once again. Do I? Okay. Then the thesis by Abdelghany, Abdelrahman, Mohamed, titled "The Influence of Surface Properties of Biocompatible Polyesters-based Particles on Biointeractions and Drug Release Kinetics," meets the requirements of the order as of November 19th, 2021, on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Abdelghany deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 147 Macromolecular Compounds. And I believe I'll translate my additional question myself. Yes, why not? Okay.
So I have a question about the application of the nanoparticles with penicillin. It is mentioned in the paper at least that it is designed for ocular drug delivery. So I'm not clear if this ocular drug delivery is just topical drug delivery or it is injection-based. And in both cases, it is also unclear why you need to study the release of drug for 700 hours if the residence time both on the ocular surface and inside the eye will never reach this time. Why is it important?
Okay, thank you very much for your valuable comments. Firstly, our study was performed just to present a systematic information about how the surface charge and the particle size will affect drug release and biodistribution of our particles formulations. This is the first, and this the obtained result is could facilitate the rational design of new drug delivery systems based on the obtained results. This is the first objective. In our case, we intended to present that the hydrophilic layers on the surface of particles could extend and sustain the release of drug at a sustained rate as long as we could. So we performed such a study more than up to one month. This is the second. And the third point, we intended to expand our work by applying this system as ocular drug delivery for intravitreal injection for the posterior segment of the eye. And we actually started such type of experiments to study how these particles will diffuse inside vitreous, and also how the drug release will be in fact. And for example, in vitreous and so on, instead of just BBS. We have started such type of experiments, but unfortunately, due to a pandemic, I had no lab work. I had no access to lab work, so we decided to complete such type of experiments after PhD. It's a future work.
Okay, thank you very much.
You're welcome.
Спасибо большое. Ну и
Thank you so much. And in conclusion, I'm going to mention my review. I had a very positive review. I was impressed by the work. It is interdisciplinary. It is quite relevant. And in my review, I mentioned that the work corresponds to the topic of the thesis, to the specialization of macromolecular compounds. I mentioned the goal, the relevance of work, because there's a need to develop reliable systems for hydrophobic drugs, like the one chosen as a model molecule, prednisolone. I mentioned the personal participation of the candidate for the degree, the level of credibility of the obtained results that is not questioned at all. So, as for the publications, they are quite good, and essentially, as it was mentioned, as in MDPI Pharmaceutics, that's a very good journal, first quartile journal, and also bioconjugate chemistry also deserves attention. Not every work is published there. And the report was delivered at the conference at St. Petersburg. And you delivered your report at the conference for young scientists on polymer science. I believe that's an English, some English-speaking conference. And this magic phrase that we all need to read out. A thesis by Abdelghany, Abdelrahman, Mohamed Ali, titled "The Influence of Surface Properties on Biocompatible Polyesters-based Particles on Biointeraction Drug Release Kinetics," meets the requirements of the order as of November 19th, 2021, on the procedure of granting academic degrees at St. Petersburg State University. And Mr. Abdelghany deserves the academic degree of Candidate of Sciences in Chemistry in Specialization 147, Macromolecular Compounds. And Articles 9 and 11 of the above-mentioned order are not violated. So I had no critical reviews. So, distinguished colleagues and the members of the board, are we all satisfied with the answers of the author? Yes? Yes? Fully. Okay. Do we have guests who wish to participate in the discussion, those who are not members of the board? If there are any, so I can give you 10 minutes for the speech. No one. Okay. Do we have an external reviews during the broadcast? No? Okay, then we'll skip it. Skip this part as well. So this magical point, a speech by the thesis supervisor. Tatiana, please, you have the floor. Tell us about the candidate for the degree and his work. Distinguished colleagues, first and foremost, I would like to thank you for the attention to our work and for the high appraisal of this work, for the high estimation. I wouldn't like to mention everything that was mentioned before regarding the academic part of this work. I should mention that this work really is a success. And if we talk about the candidate for the degree, there was one complicated point for us. He joined our lab, and he came from the Department of High Molecular Compounds Chemistry, where he spent 1 year. So he started from scratch, from the very beginning. He came, we offered a topic for study, the theme, and he was glad to take this topic for further studies. Because, and that's an advantage of him, he understood that that's a very promising field into disciplinary work. And good results in this field would allow him to improve his academic background and to find a place either in Egypt or in any other country. The first thing that I wanted to mention about Mr. Abdelghany is, I believe you saw it in his literature review, he was really, he was really desperate to get scientific knowledge. He analyzed lots of literature sources. We had to even to reduce this literature review because it was really huge. And as that's an interdisciplinary work, he had to read a lot of sources on chemistry of polymers, on physics and chemistry of polymers, and on biotechnologies, nanotechnologies, and so on biological application. So that's a pretty good quality of the author that I wanted to mention. And above all, he used a lot of methods, both chemical ones, physics and chemical ones, biological ones, and in the majority of cases, all the experiments that are described in the thesis were performed by the author himself, or other 10% tests were done with his active participation. And that's basically it. For me, that was quite a pleasure today, because that's the first thesis that my student has written at the university. I had a lot of PhD students at other universities, but as for St. Petersburg State University, that's the first thesis at St. Petersburg State University, so I believe that's a success. Thank you so much, and I would like to ask the members of the board to vote for the award of the academic degree to Mr. Abdelghany. Thank you so much. Thank you, Tatiana Borisovna. We congratulate you on your first PhD student at St. Petersburg State University. Dear colleagues, anyone else willing to say something? Okay, here we stop the discussion, and here we stop taking questions. And before we draw conclusions, and before the final vote, I need to ask your opinion about the following fact. So, distinguished members of the board, the candidate for the degree, do you have any questions or comments regarding the procedure of our defense? Maybe some questions on the remote access? No questions. No. No, everything is okay. Okay. No questions. Okay, that's a compliment then. And now, next item on our agenda, the vote. Distinguished colleagues, before the vote, we have an option to announce a break that will not be broadcast in order to discuss the results. Do we need such a break or not? No, I believe not. Okay. There's no need to discuss the results of the defense. Therefore, let's shift to the vote. And at that, I will need to solicit your opinions personally and publicly. Well, then it's 18 minutes past 4. And as we need no break, let us vote. So I raise a question on the award of the academic degree of candidate of sciences in chemistry in specialization 147 macromolecular compounds to Mr. Abdelghany. And I would like to emphasize that voting for the award of the academic degree to the candidate, each member of the board agrees that Article 11 of the order is not violated by the candidate. And I would like to quote it. Article 11. In the thesis, the applicant for the academic degree is obliged to cite the author or the source of the material or individual results borrowed. Is in the results obtained by the applicant personally and or in co-authorship. The applicant for the degree is obliged to note this circumstance in the thesis. And that's it. I believe that's quite an obvious item, but still we need to remember that it should not be violated. And let me remind you that the decision of the dissertation board on conferring the academic degrees positive, provided more than 50% of the board members, but not fewer than 3 people voted in favor. And that's in conformity with Section 23 of the above-mentioned order. So, and Professor Grachova, what's your opinion about the thesis? Yes, I vote for the award of the academic degree. Then Professor Tsvetkov. I also vote for. Professor Garabadzheo. Yes, colleagues, I vote for the award of the academic degree. Great. Professor Khotaryansky, what's your opinion? I also vote for the award of the academic degree. Okay, and finally, I, Chair of the Board, Mikhail Krasavin, also vote for the award of the academic degree to Mr. Abdelghany. So, dear colleagues, dear guests, I would like to announce that 5 members of the board voted in favor. No one voted against the award of the academic degree, and no one abstained from the vote. Thus, we award the academic degree of Candidate of Sciences in Chemistry in Specialization 147 Macromolecular Compounds to Mr. Abdelghany. And I would like to give you the floor. 3 minutes for the finalizing remarks.
My deepest gratitude and sincere appreciations must be addressed to Professor Tatiana Borisevna Tennikova for her guidance, support in solving the problems required for preparing a thesis, reviewing the manuscripts, for generous advice and valuable comments during the entire period of this work. I'm looking forward to continue our cooperation. I would like to express my sincere gratitude and appreciation to Dr. Viktor Kolchevikov-Flach for valuable comments, constructive criticism during the entire period of this work, endorsement, and his uninterrupted support throughout the laboratory work. I would like to express my gratitude to the chairman and the members of the Dissertation Council. I sincerely appreciate your consent for to participate in this in the work of this council, for the exclusive valuable remarks and comments, and also for the discussion. I will definitely take into account the recommendations and advice in my future work. I'm extremely gratitude to all of my colleagues at the biomedical chemistry lab for unlimited support and encouragement. Many thanks to all staff members in the Department of Dissertation Councils for the excellent work for the entire process, for defense, and for organizing today's meeting. I owe great support, sincere love, and my deepest thanks to my family, mother, father, my sisters, and my brother, and my wife, who stood by me during hard times, and who gave me all the potential support to accomplish this study. And especially to my lovely kids, Asil and Deline, for their patience and encouragement during this time. Finally, no words can ever express my sincere gratitude to Allah, who guides, aid, and bless me in everything and everywhere in my life. Thank you.
Спасибо. Я предлагаю...
Thank you so much. Let us congratulate Mr. Abdelghany. And here I would like to announce that we finish our session. And please turn off the broadcast.